All right, let's try this again. What we're going to do today is review for the test over Pulleys Math. Pulleys Math, in my opinion, is fairly simple. What we're going to be doing is comparing this height and this force weight to the force it takes to pull the pulley and the distance you choose to pull it. All right, so you're given a mass. So each one has been given, you're always going to be given a mass. You'll often have to turn that into a weight, and as we know from everything that we've done this year, that force weight is equal to the mass times the gravity. We're going to use 10 for the gravity, so in figure A, the gravity would be, or the force weight would be 100 newtons. So this guy is 100 newtons. I'm going to pull that up to a height of 0.5 meters, pulling that up. So for work output, anytime we find work, it's force times distance. We just got to make sure we're using the right force and distance. So we don't want to use this one for this. We want to use this one. So the work out is what I got out of pulling the pulley. So the work output would be this force times this distance, which is 50 joules. Now, let's take a break and come over here to mechanical advantage. Mechanical advantage is found by the number of supporting strings that help you lift this object. Now, because these two are pulling down, we only worry about the strings that are attached to the weight. In this one, notice we're pulling up. And because we're pulling up, that actually counts as a string as well. So you have 1, 2, 3, 4, as opposed to here you would have 3, even though you could see 4, because this one wouldn't matter. Same here. These two would not matter. So with all that being said, the mechanical advantage on this first pulley is 2 because it has 2 supporting strands. A mechanical advantage of 2 means that we're going to be splitting the forces and doubling the distance. So we're going to split the forces and double the distance because of the mechanical advantage. Mechanical advantage of 2 means that we would split this force by 2 strings. But we would also have to pull it twice as far because I have 2 strings doing the work. So with that being said, the input force would be the weight divided by the mechanical advantage of 2. So you wind up getting 50 newtons. And then the distance applied, well, I would take the height I lifted it, 0.5, but I had to do it twice as much because I had 2 strings. So this would be 1, which means that my input work was 50 joules. So always what I put in is what I get out. So efficiency is 1, work output divided by work input. Let's go ahead and try B. If you want to pause it right now, go ahead. But here's figure B. We're going to have a weight of 150. We have 3 strands, so it's 3 mechanical advantage, 3 supporting strands. I move it 1.5 meters, which means I have 2.25 joules of work. My input force would be divided by 3, so that'd be 50 newtons. And then the distance I have to move it is times by 3, so that's going to be 4.5. So my input work would be 225. Work output divided by work input would be 1. So let's come down here. You can do C on your own. Let's come down here to the first or second sample problem. Figure B, the scenario says that it really took 282. And we're talking about the second scenario where earlier we'd said that 225 joules to get that done. Well, in this story, I'm saying, yeah, but these would be perfect situations. No rust, no stretching of the string, no heating of the string, no air resistance. But if I go out there and I really go out and do it in the field, I'm going to find out that it actually took me a little bit more work than what the math said. And that'll always hold true, that you'll always have a little bit more work you'll have to do than the work you'll get out. It's still going to be work input divided by work output, but I'm going to use the work input that I'm given here because this is what I actually put in. Math said it should have been 225. That's the work output. I divide those two and I get 0.79 or 79%. Remember that our efficiency always has to be less than 1. All right, guys, I hope that helped. And if you have any questions, tweet them to me.